Now next is the what is an atom. Have you ever wondered how the ant prepare its building? That is the ant hill. How the ant prepare its building? By using a small grain of sand. In the same way, if we have to prepare the matter, then the smallest building block of all the matters are atoms. Like the smallest particle to prepare its building is the smallest grain of sand. In the same way, all the matter, the smallest block is the atoms. So atoms are the smallest, or the building block of all the matter is known as the atoms. Now you know that all the atoms are very extremely small in size, and even a small drop of water contains as much as particles that you can't even imagine. Then how we can determine the size of a single atom? Have you ever thought? Yes, the atoms are so small that we can't imagine so many particles, and we have to determine the size of one atom. Then the best way is to determine in nanometers. Atomic radius. What do you mean by the term atomic radius? If we consider the atom as a spherical, then the centermost part is known as the nucleus, and the distance from the nucleus to the outermost shell is the radius. Right? In the mathematics, you might know what is radius. The centermost part, the distance from the centermost part to that of the outer part is the radius, and that radius is known as the atomic radius. So if we determine the atomic radius, then we know the size of the atom, and it is measured in nanometers, and 1 meter is equal to 10 raised to power 9 nanometer. Or else if we want to know 1 nanometer, then just take this part down, and this is the 1 nanometer, right? So many modern technologies have come today now to see the magnified image of the elements which showing the various atoms, and see if you can see the picture, then even in this picture also, because there are so many atoms in a single element, so the picture looks very blurred, right? Because there are so many atoms in a single element, so that picture also looks very blurred. The next is the symbols of atom. So the Dalton was the first scientist that plays a very important role in determining the symbol. He thought a part of this Dalton's atomic theory, let's contribute more, and he also plays an important role in determining the symbols. And how the Daltons determine? In this way. Like the symbol of hydrogen, what he determined the symbol of hydrogen, he put the spherical and inside that a dot. Phosphorus in this way. Copper, just write a sphere and write the C. Gold, you can see just dot around, and in between that a capital G. So this is not a simplest way to learn the symbols. So finally it gets rejected, and the modern day of the symbols was first determined by the scientist Berzelius. Was the first who gave the modern way of symbols that was further approved by the International Union of Pure and Applied Chemistry, known as the IUPAC name, which was approved, and the modern symbol was given by Berzelius. But the Dalton symbols were completely refused. So what is the criteria of this IUPAC name? IUPAC symbols. The three ways by which you can read a symbols in a very simplified way. The first way is the first letter. First letter has to be written in a capital letter, like hydrogen, carbon, oxygen. This is the first letter which has to be written in a capital letter. Then the second point is the combination of first letter and the second letter, in which second letter has to be written in small, like in the aluminium. Aluminium, A is capital, L is small. Cobalt, C is capital, O is small. If you write in this way, both the letters capital, then this is a different compound, then it will be completely different from cobalt. So don't write like this when you are writing the cobalt, right? So the first combination of first letter has to be in capital, combination of first and second letter where the second letter has to be in small, third combination of first and third letter and the third letter has to be in small. Like in the case of chlorine, C has to be capital while chlorine, L has to be in small. Zinc, Z has to be in capital and N is to be in small. So this is the way by which the IUPAC also approves such criteria of writing the symbols. Then this is not all about the symbols. Some of the symbols also uses the name of the Latin word as well as German or the Greek word. Means some of the elements are derived from their Latin name, from their German name, from their Greek name. Like for example, in the case of sodium, sodium is derived from natrium. Potassium is derived from K. It is not written as a P. It is written as a capital K. Kalium. Copper is derived from the Latin word cuprum. So capital C and the small u. Ferrum is also derived from Fe, which depicts iron. So here we don't write capital I or R. We write Fe, which is derived from the Latin word ferrum. Next question may arise in your mind, how we can determine the mass of an atom. Atoms are so small that now you know that the size of the atom can be determined in nanometers, but the size is so small, then how we can determine the mass of single atom? Whenever you go to the market, you use the term I want 100 grams of nuts. So you use the unit grams. But this gram is a very huge term for this atomic level. At the atomic level, at the microscopic level, this gram unit cannot be used because it is a very huge term for a small piece of atom. So in that case, a separate unit was determined by the scientists, and that unit is known as the AMU, atomic mass unit. Earlier it was abbreviated as AMU, but nowadays it is abbreviated as small u, known as unified mass. So Dalton plays a very important role in determining the atomic mass. Earlier, atomic mass unit is abbreviated to determine the mass of single atom. But nowadays, it is abbreviated as a U or the unified mass. See, if you have a single piece of sodium element, in that sodium element, piece of element, you have so many atoms, a million, billions of atoms, right? So if you want to know the mass of this single atom, then it is a very crucial task for the scientist. So to simplify this task, they introduce a term relative atomic mass. What is this relative mean? Relative means to compare with someone else. With reference to, you can say it as. If I say I am taller than my brother, then I am comparing my height to my brother, right? So in the same way, if we compare this single piece of atom with someone else, then it is very easy to determine its mass. Let us take an example to understand this relative atomic mass term in a more simplified way. If your mother brings a piece of a fruit of watermelon, and in your family you have 12 members, then what she do? She just cut the watermelon into 12 equal half. And you will get a single piece, right? Then how will you call this single piece? You will say that I get 1 by 12th part of this entire watermelon. Of this entire watermelon, I get a 1 by 12th part of this entire watermelon, right? And if you want to know the weight of this watermelon, right? So keep it there. And suppose you want to calculate the mass of apple. Mass of apple. So you will say that this piece of apple is 10 times heavier than 1 by 12th of entire watermelon. 1 by 12th of entire watermelon, right? You will say, if you want to know the mass of these apples, then you will take this apple on one side and compare with a piece of watermelon, and you will say it is 10 times heavier than 1 by 12th part of this watermelon. In the same way, this 1 by 12th part is taken as a reference. It is taken as a reference so that you get to know the mass of apple. In the same way, scientists did what he did. They took C12 as a reference and said that 1 by 12th of mass of C12 atom he took as a reference. Entire C12, this is an entire C12 atom, and 1 by 12th of carbon atom he took as a reference. He took as a reference, and we can determine the mass of any element. Here we determine the mass of apple. You can determine the mass of any element. Suppose you can determine carbon, nitrogen, oxygen, sodium by comparing the 1U. And what is 1U? 1U is 1 by 12th of C12. This is the main funda which you have to understand, that 1U is nothing but 1 by 12th of C12, which is taken it as a reference to determine the mass of any element. If I'll say this is the carbon, this is the 12U, then carbon is 12 times heavier than 1 by 12th of C12. If I say 14U, then nitrogen is 14 times heavier than 1 by 12th of carbon 12. So 1U is nothing but 1 by 12th of C12. If I say 16U, then oxygen is 16 times heavier than U. U is nothing but 1 by 12th of C12. So this is the most simplest way to understand the mass of an atom, by comparing that atom with someone else, and someone else is taken it as a reference. And what is that reference? Reference is the C12 isotope. And if I'll say 1 by 12th mass of one carbon atom, then you can say it as a 1 atomic mass unit, or 1U. So 1U is nothing but 1 by 12th of C12 atom. Clear? So thank you so much. If you like my video, please subscribe my channel and share my video.